Hi guys, this video will discuss about trigonometry and we will start with the very basic concept about trigonometry such as trigonometry ratio. So what is trigonometry ratio? So trigonometry is the branch of mathematics that focus on the relationship between the sides and the angles in the triangles. The ratio that we can have is in the right angle triangle. So if we have an angle of theta in the right angle triangle, we have side B as the opposite side to the angle theta, and then we have side A as the adjacent side of angle theta, and we have the hypotenuse, the longest side in the right angle triangle. There are 6 trigonometric ratios. We have sine, cosine, we have tangent, cotangent, secant, and cosecant. But we will focus on the first 3 trigonometric ratios in this video. We will study about the cotangent, secant, and cosecant in the further trigonometry chapter. So what is sine of theta? So if you see from the right angle triangle, the sine has a definition of it's the ratio of the opposite side and the hypotenuse side. So the ratio of the opposite, which is B, and the hypotenuse over C. We can express the ratio in the fraction form. So the sine of theta is equals to B over C. The cosine of theta is divided by the ratio of the adjacent side to the hypotenuse. So it's A over C. And the tangent of theta is denoted by the definition of the ratio between the opposite side with the adjacent side. So it's B over A. For the other trigonometric ratios, we have cotangent, secant, and cosecant, and they are the reciprocal of the first 3 trigonometric ratio. The cotangent is the ratio of adjacent and the opposite. So we can see that this is the reciprocal of tangent. Secant theta is the ratio between the hypotenuse and the adjacent. So this is the reciprocal of cos. And for cosecant is the ratio between the hypotenuse and opposite side. So this is the reciprocal of sine theta. But because we will focus on the first 3 trigonometric ratio, so we will see only sine, cosine, and tangent. And we can use the term of SOHCAHTOA to to remember the ratios easily. So SOHCAHTOA, so is sine, O is opposite over hypotenuse. CHA is cos is adjacent over hypotenuse, and TOA is tangent opposite over adjacent. Yeah, we can use this term to easily memorize the ratio in the trigonometric ratio. Trigonometric ratio of the obtuse angle. So if we see from the definition, the theta in the right angle triangle is usually, or it's always, an acute angle. So how do we find the trigonometric ratio of the obtuse angle? So obtuse angle means the angle greater than 90 degrees. So between 90 until 180. So the angle should be lies in the second quadrant. An obtuse angle is the angle in the second quadrant. Greater than 60 but less than 180 degrees. Now if we see from the figure, if the theta is an obtuse angle, so at the back of the triangle, we have an acute angle with the related acute angle. We call it related acute angle. So in this case, I can say that the related acute angle is equals to the 180 minus theta. So that means we can find the trigonometric ratio from the related acute angle. So according to this, so the definition of the trigonometric ratio of the right triangle is opposite and adjacent can be denoted by y and x, because in the Cartesian diagram, the coordinate x and y indicating the position of a point in the xy diagram. So the opposite sides of the right angle should be equals to y, the vertical distance from x-axis, and the horizontal one should be equals to adjacent, and it is equals to x. So the definition of the sine theta will be always y divided by r. R is the hypotenuse. Yeah, don't forget that sine is opposite and hypotenuse. So the hypotenuse is r. So sine theta, definition of sine theta is always y divided by r. Cos theta is x, the adjacent, divided by r. And tangent is opposite, y, divided by adjacent, x. So if we refer to this definition, so we can have for the obtuse angle, the sine of theta, if theta is an obtuse, so we can see from the related acute angle here, alpha. So I can say alpha is 180 minus theta, yeah, the related acute angle. So sine of alpha is equals to the sine of 180 minus theta. So this is equals to y over r. So this is y over r. Yeah, back to the definition. The sine theta is always y over r, the opposite over the hypotenuse. So that means sine alpha equals to sine 180 minus theta, and this is equals to y over r. Y over r in the acute angle. So if we have acute angle, this is y, this is theta, this is x, this is r. So this is equals to sine theta. Cos cos alpha is cos 180 minus alpha. So it will be x over r, adjacent over hypotenuse. So x in here will be negative x, since the value will be in the x negative. So it will be negative x over r. Now, the negative x over r is negative cos theta according to definition. So sin theta here is y over r. Cos theta here is x over r. So negative x over r is negative cos theta. And tangent, for tangent 180 minus theta, it will be y over negative x, opposite divided by the adjacent. Adjacent is negative x. So it's negative y over x, which is in the acute angle, tan theta is y over x. So this is negative tan theta. That's it. So from here, we can see that sine 180 minus theta will equals to sine theta in the obtuse angle. Cos 180 minus theta equals to negative cos theta. And tangent 180 minus theta will equals to negative tangent theta. For example, for its obtuse angle theta, state the 6 trigonometric ratios. So we can find from sine theta, and then cos theta, and then tangent theta, secant theta, cosecant theta, and cotangent theta. So we start from the sine theta first. Sine theta, we know that theta is the obtuse angle. So we are looking for the related acute angle. Yeah, in this case is alpha. Yeah, from above. So that means the sine theta is equals to sine 180 minus theta. Yeah, or equals to sine alpha. So this is equals to, so negative 5 and 12. That means this is 12 and this is negative 5. So the length of the line will be the Pythagoras. So this is 13. Yeah, Pythagoras, 5 square plus 12 square equals to 13. So the sine alpha in here will be 12 over 13. How about cos? Cos, so this is cos 180 minus theta, but cos is negative for obtuse. So this is equals to negative cos alpha equals to negative 5 over 12, 13. Tangent. Tangent is also negative. So negative tangent 180 minus theta equals to negative tangent alpha. So this is equals to 12 over negative 5. Secant is 1 over cos theta. So this will be equals to negative 13 over 5, the reciprocal of cos theta. Cosecant is 1 over sine theta, so which is 12 over 13. This is the reciprocal, so it's 13 over 12. And cotangent theta will be 1 over tangent theta. So this is equals to negative 5 over 12. That's for the first one. B. We have -4 and 3. So the alpha here, so sine theta, cos theta, tangent theta, secant theta, cosecant theta, and cotangent theta. So sine theta is positive sine alpha. So it's 3 over, okay, the Pythagoras of this is 3 squared plus -4 squared equals to 5. So 3 over 5. Cos theta is negative cos alpha equals to -4 over 5. And tangent is negative tangent alpha, which is equals to 3 over -4. And secant theta as well is 1 over cos. So it will be -5 over 4. Cosecant is 1 over sine. So it will be 5 over 3. And cotangent is 1 over tangent. So it will be -4 over 3. And for C, you may try it by yourself for practice. Yeah. Degree and radian conversion. So in measuring angle, we can express the angle in the terms of degree or radian. We usually use degree. But what is radian? Radian has the definition of the ratio between the circumference that subtended by two of the radius, two the length segments of the radius, over the radius of the circle. So the theta angle subtended by the radius in radian is the ratio between the circumference and the radius of the circle. So for example, like this, if the length of the arc equals to r equals to radius, so the ratio of the angle alpha is equals to the ratio of the r to the radius. So this is 1. So this is radian measure 1. And for beta, the beta in radian is, we have S equals to 1, 2, 3, 4. So this is for R compared to R in ratio with R equals to 4 radian. So this beta has the radian measure 4. Since one revolution is for 360 degrees, it swipes and the entire circumference of the circle. Yeah. So the S will be equals to 2 pi r, the circumference of the circle. So the radian measure is equals to the S, 2 pi r, divided by the radius. So equals to 2 pi radian. So that means for 360 degrees, this is equals to 2 pi radian. And also half of the revolution, so 180 will equals to pi radian. So for example, convert these following angles to the radian. So I have 210 degree. So we can use the conversion of 1 pi is equals to 180. So that means I can find 220 over 180 and then multiply by the pi. So it will equals to, we divide by 3. If we divide by 3, this by 30 is, this is 7 and this is 6. So this will be 7 over 6 pi. radian. And then for C, 60. So it's 60 over 180 times pi radian equals to 1 over 3 pi radian. I leave B for you for practice. And then now we convert back from radian to the degree. So using the conversion, pi radian equals to 180 degrees. So 1 over 4 pi means 1 over 4 times 180. So equals to 45 degrees. And for B as well, we can use pi over 3 pi equals to 5 over 3 times 180. So this is equals to, divided by 3 is 60, so 300 degrees. And how about C, 2.13 radian? It doesn't contain pi. So still using this ratio. So we can express in the 2.13 over pi and then times 180. So this is equals to 122 degrees. Yeah, approximately that. Next, we move to the trigonometric function and graph. To start with this, we have to know about the unit circle. The unit circle is the circle which has the radius of 1. And the radius, so this is 1, this is 1. And we can have a random point A, coordinate A, with coordinate X and Y. If we projected the coordinates into the x-axis, it will be cos theta because of the angle theta here. Remember the trigonometric ratio. This is y, this is x, this is 1. So that means if you want to find x, we use cos theta equals to x over 1. So cos theta equals to x. And sin theta is equals to y over 1. So equals to y. So cos x equals to cos x and y equals to sin theta. From here, we can have the spatial angle of the trigonometry. So if we see from the x-axis, we see from cos. So the function will be x equals to cos theta. And if we see from y, it will be y equals to sin theta. Now what is the theta is 0 here? So theta 0 will lie in the x-axis. So that means we see from the cos. So I can say that x equals to 1. That means cos of angle 0, cos theta, yeah, equals to 1. So this is cos 0 because theta is 0, equals to 1. And for this is the y direction. So we can see from this y equals to sin theta. And theta here is pi over 2 or 90 degree. Yeah? So that means I can say for sin 90, the value will be equals to 1. So from here, we can put it into the table that for sin 0, yeah, for sin 0, sin is y, sin theta. So sin 0, 0 is this. So sin 0 is 0 because there is no y. the y is 0 in y direction. But cos 0 is x. Cos theta, yeah? Cos 0 is x, so the whole thing, 1. And 90, sine 90, we have sine 90 is the maximum of y, so this is 1. And cos 90 is no x direction, yeah? So this is 0. And then tangent, how about tangent? Tangent of theta, we know from the trigonometric ratio, tangent is opposite over adjacent. And this is equals to, if I divide everything by the hypotenuse, so I will have sine theta over adjacent is cos theta. So tangent is the division of sine and cos. So sine over cos is tangent. So tangent theta is sine theta over cos theta. And this means tangent 0 is 0 because 0 over 1. And tangent 90 degree is 1 over 0, so it's infinite. How about the other angle? We can have a triangle like this for the 45 degree. I prepare for the 60 and 30 degree. That angle, yeah. For the 45 degree is an isosceles right angle triangle. So the side of this opposite and adjacent will be the same. So what is sine 45? Sine 45 is opposite over hypotenuse. In this case, because this is ratio 1 to 1, so the Pythagoras will be square root of 2. So the sine of 45 will be 1 over square root of 2, which is equals to 1 over 2 square root of 2. And that's the same as the cos 45. It's also 1 over square root of 2, so this is 1 over 2 square root of 2. Here. How about the 60 and 30? So 30 and 60 are taken from the equilateral triangle. So this is 2, the ratio. This is 2. This is 2. So I divide it into half. So this is 1. And this is the Pythagoras is square root of 3. So what is sine 30? So sine 30 is 1 over 2. So this is sine 30, 1 over 2. And cos 30 is equals to root 3 over 2. So cos 30 is half root 3. That's it. How about the, so now we have the complete table for angle in degree, and we can convert it into the radian. And now we can convert it to the radian. So we can copy this all 1, 0, 1, 0, and then 1, 0, infinite. So that's all the same. Yeah, only the unit different.